Logistic regression is a statistical method used to predict the probability of a binary outcome. Unlike linear regression, which predicts continuous values, logistic regression is designed for situations where the dependent variable is categorical, meaning it can only take on a limited number of values, typically two. Examples of binary outcomes include yes or no, true or false, and 0 or 1. Logistic regression uses a logit function to estimate the odds of an event occurring based on one or more predictors. The logit function is the natural logarithm of the odds. The logit function transforms probabilities, which are bounded between 0 and 1, into log odds that can range from -infinity to +infinity. The logistic regression model transforms the linear regression function's continuous value output into categorical value output using a sigmoid function. The sigmoid function maps any real-valued set of independent variables input into a value between 0 and 1, which can be interpreted as a probability. Logistic regression creates a decision boundary that separates the classes. Points above the boundary are classified as one category, while points below are classified as the other. There are three types of logistic regression: binomial, multinomial, and ordinal. Binomial handles two categories, while multinomial and ordinal handle three or more categories. In ordinal regression, the order of categories matters. Logistic regression makes several key assumptions. It assumes that the outcome variable is binary or categorical, and that there is a linear relationship between the independent variables and the log odds of the dependent variable. Other assumptions include independent observations, no perfect multicollinearity, and a sufficiently large sample size. In logistic regression, the sigmoid function plays a crucial role. This S-shaped curve transforms linear combinations of inputs into probabilities between 0 and 1. The formula shows how we convert the linear predictor into a probability using the exponential function. In logistic regression, the coefficients are estimated through a process called maximum likelihood estimation, or MLE. MLE estimates model coefficients by finding values that make the observed data most probable. The algorithm tests different coefficient values through multiple iterations. The log odds, also known as the logit function, relate the probability of success to a linear combination of predictors. The coefficients in logistic regression have meaningful interpretations in terms of odds ratios, showing how each variable affects the likelihood of the outcome. Logistic regression allows us to calculate odds ratios when we have